Okay, do you guys remember when we went to the computer lab and we did the balances for solving equations and how we learned that you want to keep things balanced for those properties of equalities? You add something, you divide by something, you do it on the same. We're going to be going to that same website, but now we're going to be looking at it, looking at that kind of same idea with functions. And I'm going to bring it up through here just so we have this. Okay, here's a tile pattern. Okay, and what the directions say for activity 1, and we're going to complete this activity right here in this first row. For the sequence of figures shown, the x value is the number of triangles, the y value is a perimeter. Okay, enter the 5 data points, graph the data, choose the function f of x whose graph will pass through those points. Okay, what we're trying to do is we're trying to look at it through a table and then the scatter plot, and then we're trying to come up with a rule that goes through that scatter plot and matches that table. Okay, what I would like you to do right now is take 3 minutes to think about what do you think would go in the table and draw the scatter plot right here. Okay, and you can work together on that. Okay, and remember, figure 1, what's the perimeter of this one? 3. 1, 2, 3. So figure 1 has a perimeter of 3. Figure 2, what's the perimeter of figure 2? 1, 2, 3, 4. So figure 2 has a perimeter of 4. So those first 2 columns are solved for you. Okay? Or given to you. Okay, so Gabriel, what are we doing right now? Yeah. And Alan?
I'm trying to see it.
What is that table?
We're just filling this out based on that.
Yeah. The 1 is a 2, the 2 is a 4. Oh, sorry, the 1 is a 3, the 2 is a 4. Now, count the perimeter for the third figure. Okay, I see most people have their table done.
Did you get 4 for number 3?
What?
Isn't it 4 for number 3?
And you have your scatter plot done.
What?
Okay. All right, what do you think the perimeter of figure
Look at the perimeter of the next
3
one.
is?
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7.
Got it?
Yeah.
Okay. Everyone has their table done. Majority of people are just about done with their graph. What I want you to do now is think about a rule, just like what we did in the warm-up, that we could use to figure out what comes next in this scatter plot. Oh, and I forgot to give you guys whiteboards. Yeah.
No, it's not.
Yeah.
You can't count the same points, right?
No. And it's just around the outside. It's not those interior sides.
Oh, okay.
Okay, you guys, what kind of relationship is this? Jacob?
Explain my...
It's not proportional, but it is linear.
Okay, it's not proportional, but it is linear. What I would like someone to do is I'm going to have someone come up and be the driver. And I think what I'm going to have is, Jacob, I'm going to let you be the driver because you told me what type of a pattern this is. So you're going to come up, and what you're going to do is you're going to type your numbers into here. And then what I want you to do is hit graph the data. And then we're all going to share what equations we have and see if it works. Okay?
Whoa. Good thing I'm not driving. I'm Asian.
So what equation? You guys, as a table, you're going to have to come up with an equation to give Jacob. Okay, let me tell everyone this. As a table, your table's going to write an equation for Jacob to type into here, and we're going to see if your equation matches the data that you guys came up with. Yes.
What? Yeah, X plus 2. Or, no.
And I need to get you guys a pen. Give me a second.
Yeah, it's X plus 2.
Stay up there, Jacob. You're not off the hook yet. Okay.
Wait, do the X.
Jacob's data that he put in here was
Let me see it. No, like,
Jacob, other Jacob, 4, 5, 6, 7. Do you guys agree with that? Is this what your scatter plot looked like? Okay, every table write an equation that they think matches this and hold it up.
I'm just gonna do
You need a pen.
X plus 2.
Okay.
Here, hold on.
Thank you.
Okay.
Oh, I'm not gonna share. Okay.
Brianna, you share. We made it a little log.
Please excuse the interruption. At this time, if we can please dismiss the 8th grade boys basketball team. Thank you.
That's your time.
Okay, you guys, boards up. Jacob, I want you to pick one of the equations to type into right here where it says f of x. You guys are creative. X plus 5 minus 3. And theirs is just crazy. I don't know what it says. Okay. Okay, before you press this,
We're so cool.
are you ready?
No,
If we're correct, what's going to happen when we graph the data?
it's going to draw a line through all the dots.
It should go through the scatter plot. Okay, go ahead.
Good job, guys.
Okay, Jacob, thank you. You can go back to your seat. Okay, this is linear. You guys, we looked at nonlinear functions too, right? So we're going to look at another activity. Same thing. Now we have this one. Okay, this one says figures 1, 2, 3, 4, and 5 are displayed. Each square represents one square unit. For each of the patterns, the x value is the pattern number and the y value is the area of the pattern. Okay, for example, the second pattern will have an x value of 2 and a y value of 4. This is our second figure, and the x value is 2, the y value is 1, 2, 3, 4, 4. So I'm going to put 2, 4 right there. What I'd like you to do now is come up with the table for the rest of these, draw a scatter plot, and I'm going to tell you what the scale is, just in case you can't see it. Right here, this goes by ones. This one goes by 4, so 4, 8, 12, 16, 20, 24. So your vertical axis, your y-axis, you want to go by 4 so you can fit the data on there, okay? And let's go for about 3 minutes for that.
And the bottom one goes by ones, you said?
Yeah, the bottom, the horizontal axis goes by ones. Ellen, stay in your seat. You can see. I have you right here so you can see.
I can't really see it. It's just, I'm not getting it.
I know. The next ones will be a little easier. How are you doing, Brianna? You have your table filled in? Yes.
Is it?
Stop it.
John, you can think a little deeper than that.
Oh, it is.
Gabriel's is worse.
Okay, yeah, you can think a little deeper. We want to think mathematically about that. But Gabriel, what we're working on is we're working on
with diabetes and infinite knowledge.
We're working on the second one now, okay? Gabriel, so we're going to be doing this one right here. Good, Haley? All right.
Oh, wait, no, I did it wrong.
Your scatter plot looks a little backwards. And you went by 5s, okay.
Yeah.
Yeah, and I said your horizontal axis goes by 1s, and your vertical axis, I said by 4s, but you can go by 5s. Okay, I think just about most people are done.
3 is 9. Dude, number 3 has 9.
You want to be the driver? I'll decide. Let me think about it.
Jonathan, 53 has 9.
Okay.
8. Oh,
Okay, you guys, I think just about everyone's done.
the rules.
Let's go ahead and move on. Okay. What can you tell me about this graph? Haley.
I don't think it's linear or proportional.
Okay, so you don't think it's linear or proportional. Why don't you think it's linear or proportional?
Well, it's not proportional because it doesn't go through the origin, and
Okay.
it's not linear because it curves.
Okay, so it has that curve to it. Do you want to be the driver?
Sure.
Okay. Haley is going to come be the driver. So Haley is going to enter her data
Alan.
and do the scatter plot. Your table's job is to come up with the equation that you think works for this data and then talk about why you think that works.
Alan. Alan.
I got x plus 2x minus 2.
Wait, why cannot be x squared? Why cannot be x squared?
Okay, I want to look at that. On object 3.
Did you do the same thing I did?
I want you to check these numbers here, okay, William?
Stupid.
So count those blocks. Hey, are you done getting your data in? Hey, Haley has 9, 16, and 25. Do you agree? Yep. Okay, so let's go ahead and graph the data. Okay, so what Haley said initially is that it's not proportional because it doesn't go through the origin. Okay, I think there's some other issues. What else does it have to be proportional? Not just go through the origin, but what else? And linear. So this kind of dies in two areas. It doesn't go through the origin. And do you guys see why this is not linear? It has that little bit of a curve to it. Okay, everybody, your job was to come up with an equation. I want you to hold that up for Haley to pick. And Haley, you can pick whatever equation you'd like to put in there.
Oh. Oh my god. Even that one.
Oh, how you do a square? You hit Shift 6. It's a caret. Yeah.
Or just do x times x.
Oh, I lied. That's it.
Or just do x times
That
x.
raises it to the power. So you're going to hit Shift, caret, and then a 2.
Sarquita.
Okay. What do you think about that?
I think it's correct.
Okay. All right. What I need you to do is put these away. Now we want to look at the structure. Okay. We're going to turn to this note taker, and this is the important part of today. Okay. Okay. I'd like you to turn to this right here, second page. And okay. This is called a linear function. We are very familiar with linear functions. Today, we are really going to focus on the algebraic rule for a linear function. Okay? I think you guys rock tables and graphs. You can come up with the equation, but we want to look at the structure of this table, the structure of this graph, and see how does that relate to this equation right here. Okay? So what I would like you to do is I put the equation, the table, and the graph in your note taker. I want you to write 2, I noticed. What do you notice about the table to the graph, or the table to the equation, the graph to the equation? What do you wonder? And so you have to write 2 I notices, 2 I wonders. What do you know? What do you wonder about how this table relates to the equation, or how this graph relates to the equation? And again, when we're doing our I notices and I wonders, I want you to really concentrate on the algebraic rule. Okay? Because by the end of the class, I want you to be able to look at a table and write a rule just like that. Okay? Let's go for 5 minutes. I want your group to, when you're done writing your 2 I notices and 2 I wonders, I would like your group to talk about some important ones you think would be useful for writing the equation, the algebraic rule. Okay? And And oh, one more thing. Just in case you can't see the scale on here, this goes by twos, 2, 4, 6, 2, 4, 6. Okay? Would you like me to ask them to move down the hall? Okay. We're videotaping in my class. That's okay. Can you guys move to that alcove down here?
Absolutely.
Okay, thanks so much. Okay, that's yes, but how would that relate to this? Okay. Okay.
What the heck? It's cool.
Okay, the rule corresponds to the graph. What part of the rule?
The 2x plus 5.
Okay. Let's concentrate on the 5. How does that relate to the graph? Okay, I'm going to give you guys a little bit of a jump start. Think about what Jacob said earlier during the warm-up. He looked at the y values in the table. Look at your y values in the table. See how those are changing. And then look at the equation and see how it relates to that equation. Okay, Jessica, can you share with your table what you think you've just figured out?
Okay, well,
That's minus 3.
okay, yeah, it's
Did you guys come up with something?
It goes up by 1 on the x and on the y.
It does have a negative
goes
slope.
down.
How do you know it has a negative slope?
It's just going down.
Okay, but how does that relate to the equation? Because we always want to relate back to that equation, because that's what we're concentrating on
It
today.
relates back to the equation because it's because there's a negative sign. Because there's a negative number in the equation. That's why
Okay, what part of the equation is negative?
this part.
The x.
Negative 2x. Negative
Okay.
2x. But then if it's negative 2x, I mean, but minus, that's why it starts up here and mine goes down.
Okay.
How do you know if it's a negative slope and how come it can't be a positive slope? Because it's
Okay,
upside down?
write that as an I wonder. That's a good one.
Ooh.
Okay.
See, one I wonder.
Okay, the graph goes in a negative. Look at the equation right here. What do you notice about that equation and the graph going in the negatives?
It's a negative 2.
Okay. Okay, at this point, what I want you to do is, some people have some really good I notices and I wonders. I want you in your group to talk about your notices and wonders. Add to yours if you need to, okay? So I want to hear group discussions about some notices and wonders. And again, I keep telling people this, look at that algebraic rule, because we're always wanting to come back to that algebraic rule. Tonight your homework is going to be writing algebraic rules from tables and graphs. So how can you look at that table? How can you look at that graph and figure out an algebraic rule? Okay, and I need to hear some discussion, guys. I know you guys can talk.
So I noticed the equation is 1x. I wonder if the equation had 2x's.
I said, why is it a negative slope when the line is going both
No,
ways?
it's you coming up with how to come up with the equation instead of me telling you. It's not as good if I just say, do it this way.
I don't like just doing this, that's all.
I noticed that any algebraic equation with squares it's never linear.
And the y goes down.
Okay.
It's like every time you have you start with like a squared of something, or if you square your x, not if you square like your constant, but if the x is what's being squared, it'll always end up being curved.
Well, this one isn't quite curved. It's
Oh,
more
it
just
doesn't have it doesn't have a square though. That's what I'm saying.
Okay. Good, Haley. Jacob, did you share one
The
yet?
relationship between through positive x's was really different because some of the positive x's would
Okay,
equal
so I'm seeing a lot of
positive
people
y's, and then
making
some
a
of the
connection
positive
between the
x's would
negative
equal
2.
negative y's. I just thought
What do you
was
think that
interesting.
5 is?
Yes. That 5 is just something to balance.
It's a constant. How does it relate to the table on the graph? I'm giving you guys some hints on where I want you to go. So there's a 5 in this equation. What do you think that 5 has to do with that table or that graph?
5 makes it above the negative part. It starts out in the
Okay,
positive.
and I'm going to give you guys a hint. A lot of you guys have noticed that that coefficient of x in -2 tells you how much it's changing. Okay, what does the 5 do in the equation? How does that 5 relate to the graph in the table?
How does the 5
And it makes the line pass to the positive, negative, positive.
Okay. No, I want specifically 5. What do you think that 5 means in this equation? Okay.
Right here.
Go and talk about your. Okay.
Look at the chart.
Yeah. What do you think it would? So.
I'm just gonna say that.
What do you think the -2 in the equation does?
-2.
What does that -2 represent?
That represents the slope.
Okay, but looking at the graph in the table, what does it represent?
The change
Yeah, it
Change the x by 2.
A change in y?
It changes all the negatives to
yeah, it's a change in y because it's -2.
Let's look at that. Look at that table. How are my y changing?
They're
Y
going
is
down by
changing.
down by 2.
I put that as my
minus
I
2.
notice.
Okay, what do you think the 5 does in this equation?
That was a well, and y equals ax
Well, from -2 to 4, that's 5. Wait, no, it's not.
Okay, you guys, we're gonna share some notices and wonders.
Unit rate, look.
Oh, yeah, it is. It is.
Okay, we're gonna share some notices and wonders, and then you notice at the very bottom it says, what do you need to know from the notices and wonders on writing equations? So, who would like to share an I noticed? Actually, I'll go to each table. Okay, and I'm gonna start on this side, I'm gonna start on this side. So, Alex, Brianna, Jacob, Matthew, and Daniel, your table. What's something that you noticed?
Okay. Brianna, would you like to share?
No.
Really? Okay, Jacob.
I noticed that y goes down by 2 every time.
Okay. Y goes down by 2. So that's like a -2 every time. Okay. Remember what I said, I want to relate it to the equation. So why is that important when I'm looking at this equation? So I'll go to the next table, but I want someone to answer that before I get to the end of all the tables. So Ryan, I want your guys' table to share an I noticed.
I noticed that the equation only has one x, but it goes with an I wonder, so we can also do an I wonder.
Okay.
Oh, okay, cool.
So has only one x. I'm going to put this right here in a bubble. That's an x to the first power. Okay. Okay, and how does that go to an I wonder?
I wonder if the equation had 2 x's, what would happen then?
Okay. And I heard Chloe talking with her group about that. What would happen if, and 2 x's, do you mean 2x or x squared?
Just like this one has -2x plus 5, but if the equation had like -2x plus 5x or -2x plus x plus 5, so like separate x's in the equation.
Okay.
Yeah.
What do you, we're gonna put that on hold because this is a good discussion. All right, Ryan.
We have another I wonder.
Okay. Or I wonder or an I notice?
I wonder.
Okay, we'll come back to the I wonders in a second. Okay, Chloe.
Okay, so for the whole squaring thing, I noticed that if an equation has an x that's squared, it'll never be linear.
If it has an x squared, it is not linear. Okay, I think that's really important with Alex's, I notice, is that it's going to be linear if I have an x to the first power. But if I have an x to the second power, it's not going to be linear. Okay, Donovan.
So I wanted to answer the question, why is the the y goes down by 2 important?
Okay.
Because on the equation, it's negative 2x.
Okay.
And before, what Jacob said was he saw the y's going up by 4.
Okay.
And that helped him figure out the other problem.
Mm-hmm.
And now the y's are going down by 2. So that's like an exponent or not an exponent. That's a very new word.
What's that word that Donovan's looking for?
Relationship?
Yes. Coefficient. The coefficient.
The coefficient of the x.
The coefficient of the x, good. So that right here, the y goes down by 2, negative 2 every time. That's going to be our coefficient of x. Okay, so can I put this in a box? It's getting a little messy up here. So Donovan added in, this is the coefficient of x. Okay, and look up here, negative 2, down 2. All right, so let's go to this group right here. What do you notice?
Well, we all notice that the 5 in the equation represents the unit rate.
What does it represent?
The unit rate.
Okay, does a 5 represent the unit rate?
Well, no.
The unit rate is that slope, or how much it's changing.
It represents the beginning.
The beginning, okay. Yeah. 5 represents the beginning.
So you would start at a 0.
Okay, or I'm going to call this the 0 term. Okay?
Wait.
Look right here on the 0 term.
It says.
What is the 0 term?
5.
5. Now let's look at the graph. Yeah.
Isn't it the y-intercept?
Okay, on the graph, what is that number right there?
5.
5, and what do we call that?
The y-intercept.
The y-intercept. That's also the 0 term because I'm at 0 on my x-axis. So when I come up here, that's my 0 term on a graph. So the 0 term or the y-intercept. Okay, so linear functions. If you have a table, how could I turn a table into an equation? Okay, what part of this equation would be replaced with different numbers if I gave you a different table? Let me move that there. Donovan? Okay, how could you look at this table and turn it into an algebraic rule? Yeah.
Find the difference of each y and use
Okay.
it as a coefficient of x.
Finding the constant difference. That's a new word. 7 minus 9 is negative 2. 5 minus 7 is negative 2. Finding that constant difference. And what part of the equation is a constant difference?
The coefficient of x.
The coefficient. This right here is our constant difference. Okay, how do I figure out the second part? Chloe.
You look for the 0 term.
Okay, this right here is where we're starting, and I really like how Parker said that, the starting point. That's our initial value, or the 0 term. Okay. We can go backwards into the negatives, but we still like to start at 0, okay? So what I want you to do is quickly summarize what are some things you need to know that we just talked about. We're gonna get to wonders probably next class, I think. We're running a little bit out of time. So hang on to those because I'm curious. We're gonna build on those. But what do you need to know from what we just talked about? If I gave you a table on tonight's homework, you need to write a rule. What are some things you need to know? Okay, so summarize what we just did. And talk with your group as you're summarizing.
If you find the constant difference of the
And then add
I attempted to make it interesting.
up or down.
Going up or down.
Miss Sarah, does it matter which way you're going? Because if you go the opposite way, it's +2 every time.
It does. You want to always move forward, like from 1 to 2 to 3 to 4.
But there, it's moving backwards. It's moving to the left instead of to the right.
Okay. Let me think about it. Look at the X's and do the X's from smallest to biggest. And the difference, do you remember when we were doing slope, we did y2 minus y1? That's that same idea. We want to do y2 minus y1.
Okay.
Or if I start at 9, how much do I have to go to get to 7? Thank you. 10. Okay, thank you, Gabriel.
All of the white math things are done now.
30.25.
Okay, you guys, let's move on to the next one. Okay, so this was linears. Do you guys feel like you can write a rule from a table?
Yes.
Or from a graph?
Yes.
Yeah? Okay. The next rule we're going to look at is called a exponential function. Okay? I want you to think about how we approach the linears and think about that same idea when I show you this exponential. Okay? And I want you to write 2 I notices and 2 I wonders. Okay, so here's my exponential function. Okay, here's the equation. It's y equals 4, parentheses 3 to the x. So 3 is called the base, the x is the exponent. Here's what the table looks like. If you want to ignore the negative parts initially, you can. For time's sake, you can think about the negatives later, but right now really concentrate on the 0, 1, 2, 3, 4 part of the graph, or part of the table. And then this is what the graph looks like. I'm going to tell you, you're probably going to make more connections between the table and the equation than the graph and the equation. Okay? So take a second to come up with 2 I notices and 2 I wonders. I'm going to give you 3 minutes, so not a lot of time. I want some really good ones this time, okay? Once you're finished with your 2 I notices and 2 I wonders, talk in your group about what you figured out. What are you coming up with, Brianna?
4 is the zero.
Okay, that's a noticed. Okay. Did you hear what Matthew said?
What?
He said 4 is a 0 term. Okay.
4 times 12, 12 times 3 is 6.
Okay, so that could be another notice.
And 4/3 times 4/3 is 4/9.
Okay, I think you can go deeper than this. I know you can multiply fast, but we're not talking about what you can do. We're talking about how this equation relates to that table. Okay? Think about how this equation relates to that table or to that graph. Okay, I'm walking around. Most people are done with their notices. Few people are done with their wonders. Okay, 1 minute, guys. Okay, let's look at this equation here. Look at this table. John, can you tell Alan one of your notices?
Well, one of my notices was that the slope never quite reaches 0 or undefined.
How long do you think the slope
slope will ever hit a line, actually become a line because it slopes up so much. I think it would become a line.
Well, it gets closer and closer to that.
Okay, you guys, I'm gonna give you all 30 seconds to come up with the table, or as your table, come up with one I notice, okay? And a backup I notice.
Like John posted, will never be straight.
I noticed that a lot of this doesn't really have to do with this, and exponentially, that's like how they're made. And I also noticed that it's like it's not.
Okay, you guys, we're gonna start now. Okay. Each table's gonna share an I noticed. Okay. If we have time, we'll get to an I wonder.
Look here.
I'm just gonna say the forest, but that doesn't work.
Okay, I'm gonna start over here with this table. Okay, Haley, your table. What's something that you guys noticed?
Oh my gosh, we didn't pick one. We noticed that on the bottom, on fx, every time it's multiplied by 3.
Okay, so this is not adding, but it's multiplying by 3. Okay, so in the table, the next, do we call it f of x term?
Y term.
Or the y term is multiplied by 3. Okay. Who would like which group would like to, when I get to you, make a connection with that multiplied by 3 part? Okay. So think about that. That's a really important thing. Okay, Parker. I'm sorry.
Sorry, I had to.
An epiphany?
That doesn't work.
Kind of. Yeah,
Yay.
it does. It
Okay.
does. Because.
Okay, Parker, I want you to share an I noticed.
Okay, so I noticed that if you take 3 to the x power, so if you do, let's take the number 2 for example. If you do 3 to the x power, which is 3 to the second power, which is 9, if you multiply it over from the starting point, which is 4, it goes over to 36.
Starting point.
Okay.
I didn't catch that part. You just said 3 to the x.
So that 3, that base right there is your starting point. And that's, can I call that?
Exactly.
Can I call that the multiplier?
Yeah, that's what I meant.
Okay, I get it.
That's not how you spell multiplier. Okay?
And then
so
if you do it by like
this
3 to the
3
third
right here tells me what I'm multiplying by each time. So if I get my marker, this is a times 3 times 3 times 3, and that relates to that 3 to the x.
Yeah.
Okay, awesome. All right, Donovan, your group.
I noticed the 0 term is the coefficient.
Okay, the 0 term
How does that rule work for this one?
is, we'll call it the coefficient. It's the number that's with the 3 to the x. Okay, so if I go to my 0 term, it's 4. What do you think the 0 term on the graph is?
4.
It's the y-intercept. Our 0 term and our y-intercepts are the same. Okay, Alex, and I noticed.
Okay, so our group noticed that it is curved and it'll never be straight. It'll always be the tiniest little bit off.
Okay,
And also something really important that I noticed.
okay, John.
I wanted to add on to that though.
Okay, I want to hear what John says.
I noticed with that thing, even though the mathematics does not allow the line to be straight, but it gets infinitely closer, it could run into a problem if the deviation from a straight line goes under the Planck length, because it would run into a quantum chromodynamics issue.
Whoa.
That is so.
All right, so it's never going to go into the negatives, but I think I'm going to try to translate what you said. The pencil mark might make it go underneath it.
Yeah.
That deviation in the pencil mark.
Exactly.
Okay. All right, you guys, I have one more group. I want them to tell me, what is something that you noticed?
That the fx term will never go to 0.
Okay, the f of x term never goes to 0. And that's important with exponentials. It's not, exponents aren't going to turn a number to 0. We're really getting close to being out of time. So, Alex, we will continue this discussion, I promise, next class. You guys are going to hang on to these.